Now I would like to request Dr. Damodar sir to continue the session.
Talking about the various applications of deep learning, the research challenges, and some real life data analytics. To begin with, if you have a computing problem, right, some data set is given to you. Like most of the machine learning problems we have, we begin with some data. We have some data. I'm going to use some machine learning model. Now, in which instance you normally choose to have some deep learning based solutions? Because now machine learning is very fascinating domain. Normally what happens, many people, by just name they take the model, like some deep learning, some CNN architecture, some deep vision, vision-based CNN architecture, recurrent neural networks, other convolutional neural networks, AlexNet, DenseNet 129, fixed-to-fixed, yarn networks, so many architectures. And how do you choose a specific architecture? In a sense, first of all, how do you choose a deep learning architecture for a specific problem? Why not any other machine learning applications? Why only deep learning? So have you ever thought like, because see, when we can solve a computing problem with a simple statistical learning problem, we need not have complex deep learning architectures which are normally computationally expensive, right? So I assume already you know the basics of deep learning. So I would like to know how do you choose or which instance you require to have a deep learning based solution for a given problem. Tell me, anybody? You understood my question? You have a data set. Because most of the machine learning problem, first you should have data. Right? Many of you are working in your text, but you don't know. The first problem you face is data acquisition. So the moment you take a data, now you are in search of some suitable machine learning algorithms. Now let us start with the motivation why deep learning and when to choose some neural network based solution and why not some other optimization algorithms we have. And how to use neural networks also for optimization or dimensionality data reduction. Now tell me, when to choose neural networks or deep learning? When data is large. So when data is large, as Madam said, since it's quite possible to extract large number of features and learning is quite possible, obviously, okay, that's one solution. But just because data is large, we need not go for deep learning algorithms. There are other methods where you can easily deal with large amount of data. Even a simple k-means algorithm that gives a linear time solution, linear time similarity, right? When you talk about some observable learning model. We don't require complex clusters like neural networks or deep learning. But why I'm asking this question? When we normally see a student's project, like out of 10 projects, at least 6 to 7 they are handling with some neural network solution. Right? Why not other solutions? Where we require the need of neural networks or deep neural networks. Optimization, we have other bioinspired algorithms, genetic algorithms, swarm intelligence, evolution computation models, right? Optimization, you talk only optimization, right? Okay, now let me ask the question straightforward. If you have no training data, no training, now to ask this question technically, what is the primary job of neurons? You tell me. Not just extraction. Any other? Learning. Yes. Learning is the the main reason that we use neural networks. People say communicate, transformation, interface, many other. But actually the reason, the primary job of neurons is learning. Right? How learning happens? To understand deep learning, first of all, biological neural model. What is biological neural model? Right? So somebody to define, because I don't want to start with what is deep learning also. Already had some session. Now I want to even go back and ask what is the biological neural model. Only then you will understand what is artificial neural models which are ruling the computing world today, and eventually that comes like deep neural networks. So what is a biological neural model? Thereby you understand what is training, then what is learning, then what is the training learning problem, then when to choose deep learning and come back again. Now what is a biological neural network? Without that you have not even understood the basic conventional neural networks. There is no point in talking about deep learning. You have some dendrites, axons, neuron, etc. etc. That's a biological structure. How it works? In a layman perspective, how it works? For example, when you are coming to this session, you have certain, weightages, certain features like whether should I go for this session, should I go for some class or exam, right? You have some priorities, which you call later stage weights, right? What is the feature? What is the weight? It will be a simple example to understand artificial biological neural networks. Now, what happens if I'm going to have my profile in mathematics and many of the women, I'll give some my expectations, my features. When I look for a suitable match, I would say priorities job, fine, salary, caste, working location, whether India or abroad, certain features I think. Right? Then some dimension, each is a dimension, right? Each one. I call it a feature because you know what a feature is. Then I have some priorities for that. Right? First one, X1. X1 is my feature. Fine? What is X1? I would say I want to have a person to be government employee, not a private. So X1 multiplied by some weight, X1 double. For this feature, how much preference I give weight? X1 double. I'll come to activation, I'll talk about later. X1 double plus, then caste, X2 double. For caste, I think 100% because the parents won't have different in Spanish. X2 double plus X3 double 3. I want someone who works outside India, not in India. 100% weight. X3 double plus so on. And with this sum, when this particular sum is converged to some achieve that for a specific match, if this entire sum is some 60 value get. Next person you get some 70, other person get 30. You reject all the matches whose the specific value, which you call as activation terms, is less than 60. Only above I will look into. That's called a biological neural model. How do you shortlist them? How do you process them? If you observe there, for every specific feature you have a weight. And when you accumulate them, what is the aggregate you say? That's called aggregation. Then based on that activation, right? You take a decision whether to reject or accept. This is the biological, what is the brain has? And there's some neurons, right? What they perform? Some chemical reaction. What is the output? An electric signal. However, this communication happens between neuron and neuron. That's an electric signal. Right? Out of a chemical reaction. So your thoughts are identified by the chemical reactions which generate an output signal which you call as what you call EEG, etc. etc. Right? Now coming back, this is just a biological neuron model, the structure. Now I just mimic this behavior, something called biomimicry. I mimic this behavior. Fine? I mimic the biological neuron model, the behavior, and just copy it and add a computing model like artificial neural networks where we have an input layer, where we have an output layer. Now in this case, whatever the example I am giving, what is my input layer? X1, X2 and so on, etc. Features, neurons, input layer neurons. Job, height, weight, caste, salary, etc. What is the output layer? Accept, reject, or pending, whatever it is. Right? There are classes. Now in between what happens is learning. Right? That's how the artificial neural network works. Right? Now the question is, when to use these type of neural networks? When to use these type of neural networks? As I said, the primary job of neurons is learning. How learning happens? By training. Right? So initially I mentioned if these are the features, they are going to converge to so and so classes. You are training. Right? Once I am trained on some supervised data, then I will be able to test on some specific data. Right? So these type of training learning problems, I am going to use neural network based solution, perceptual models, back propagation, feed forward neural networks and all these things. Right? Anybody has taken the course artificial neural networks? Basic and better. then you should understand this concept. What is biological neural model? What is artificial neural model? Now, when you have a computing problem like how to use so on, so like now I have like diabetic. I'm going to predict whether a person has type 2 diabetic or not. If you see UCL repositories or Kaggle data, so many data sets are available. Right? Kaggle data sets, thousands of data sets are available. Right? Type 2 diabetes, just for instance, or CT scan images, ultrasound images, just X-ray images. What if we just take those data sets, some 100 patients, assume that each record says whether the person is diabetic or non-diabetic, type 2. Then see his height is something, weight is something, etc., then he is diabetic, non-diabetic. So you are supervised, right? This person, these are the features, he fall into diabetic or non-diabetic, right? Something like that, then you are trained on some 1,000 patients. Then immediately what do you expect from your model? Your model should work for somebody whom you don't know whether he is diabetic or not. When you know his inherent features, your model says whether he is diabetic or not diabetic, right? That's called learning, based on training. So such a problems, when you get some training data, where some learning happens, then you will identify what is a possible class or a solution for that. Right? For such a type of problem, you choose what? These neural network based solutions, training learning problems. Right? Wherever learning is your objective, with nominal training, you try to achieve your objective. That is called artificial neural networks. What about deep learning then? Why not? What is the difference? Why we call it a deep learning? Now, I want someone to define what is deep learning. So, I want the session to be interactive. All of you should join. No, what is conventional perceptual models or basic models? The deep neural networks. What is the difference? More means how? How many? More than 3? If 2? If 3, it's a leap. So when we say the deep nature, deep expertise, when we call it a deep learning? If it is more than 1, can I say it's a deep learning? Why only 2?
Training will be limited.
Obviously, training is limited. Now, when we expect deep learning, I'll just come back to the formal definition. So when we talk about understanding the deep neural networks, see, the concept of conventional neural network has some improvement whenever the data is being used. That is the reason we always go beyond deep learning architectures. Having said this, before we see some architecture, as I said, the same definition. We have multiple hidden layers, like I said. Yes, we have. When we have multiple hidden layers, my question is like, I've got some accuracy 80. Then I will increase the number of hidden layers, 82 accuracy, 85, 90. When to stop? When we say deep learning, how deep you go inside?
We have to set the targets,
What targets?
which is very close to our goal.
Now, do you agree if you increase the number of hidden layers by +1 or like +2, etc., you increase the accuracy by so much, at least some limit?
Yeah, tolerance will be reduced so that.
Yes. Now, up to what number of hidden layers we have? This is a common question where many people confuse. My question is, okay, I go with deep learning architecture. Normal, what is it? Like medium set data set size is high. Yes, that is obviously a solution. But the definition actually is, we have large amount of unlabeled patterns and a handful amount of or moderate amount of training samples. We have sufficient training data and large volume unlabeled patterns, unsupervised data. Then deep learning based solutions are more effective. Are you following me? I'm not giving any slides now, just you listen to what I understand, then I will show part after other. There is a large amount of unlabeled patterns and a small amount of or handful amount of labeled patterns, supervised data. Then deep learning is more effective. Right? If my training patterns is like least, I have no training at all, data set size is very large, can I use deep learning at all? Cannot use. Some people are coming at data augmentation or other data pre-processing. But that's why I said it is not only sufficient the size of the data, but normally you said right, we normally use deep learning for large amount of data. Same time we have sufficient amount of training data. Right? Now, again I go back to the same question. Now I get some accuracy 80, 85, etc., etc. If I keep on increasing the accuracy or performance, as I mentioned the definition of deep learning, keep on increasing, but at what level we don't know. But why not understand? Where to stop? We reach until we get 100% accuracy?
Overfitting.
Again, like overfitting problems and all. So where to stop? Now here the question comes, the balance between computational efficiency and your performance. Now I can say my algorithm to be confined within like semi-linear n log n or n square quadratic, not more than quadratic. Right? Then I can increase the number of hidden layers such that my performance is up to n square. But same time you balance performance, like if with n square complex you are going to get only what an accuracy of what, let it be only 70%, but you expect minimum accuracy to be 80% to consider the model as validated. Are you following me? To consider the model as validated, you should have at least 80% accuracy. Then I cannot even satisfy yet this is 70. You should go with number of layers more and but you will cross n square. So this is how we use. Like for example, same time, I am also not going to increase the number of hidden layers just because I need to increase the accuracy by so and so. If I am going to increase another 2 hidden layers, if I get some sufficient like 82 to 85 it is going. But if I increase another 4 hidden layers, I am going to 85 to 85 point something. There is no point in increasing the number of hidden layers. The learning becomes very, very least. Are you following me? Learning is least where the number of layers are going to increase significantly or severely. Then that is the stage normally considered as a breakpoint and we need not to go ahead. Unless we have serious computational requirements are not there in the system. Same time, if you have some system with high latency problem where computational efficiency is not an issue, then we should achieve unless we get maximum accuracy according to whatever expectation we have.
Sir, is there any ratio for supervised data and unsupervised data? Means how much this data is should be available?
No. Normally, this again you are asking the definition like number of hidden layers, almost the same. This what you are asking is like we have, there is no specific determinate ratio like that. But normally we expect like minimum 20% should be conveniently good. Sufficient handful amount of data. But as such there is no hard and fast size that we should have this much amount of training data. Again, it depends on the quality of the patterns and everything. Madam,
So how to define the breakpoint?
as I mentioned now, you are coming with the diabetic, non-diabetic. You are going to use some specific architecture, some deep CNN model. Now you are going to say, I got some accuracy 75%. But your medical application is not going to accept that until you get 80% minimum. Only then they will adopt that. Otherwise they will not use it because you are not done up to the validation mark. Right? Then what you do? You are algorithm right taking n square. There are two options. Either you improve the performance of the algorithm by just making some layered changes or by a better feature extraction algorithm. I will also explain that. Now what you do? See, when you take about the input layer neurons, you take a large number of neurons, you apply some optimization algorithm, take those filter neurons, and then try to almost to the same accuracy at the area, so that you can increase that. Such that under 2 layers you can increase, you get a better accuracy. Right? So that is modification in the architecture such that it becomes computationally efficient or use better features. Either way. See, there are multiple ways to improve the accuracy. One is what? Dealing with better features. Other is what? Making the architecture is improved such that you have with the same features you get a better accuracy. Or better computational efficiency. Now they're coming back to the same question. Now we have a training learning problem, neural networks. Like when I said a large data set, like I said we have sufficient training data, we are going to use deep learning. Now my question is, if deep learning is not going to be a choice, why? There is no training at all. There is no training at all, then we are gone, deep learning, we cannot use, then we are stuck. Deep learning is not useful. Why? Because there is no training. When there is no training at all, what do you do with large amount of data? That's even more challenging. When there is no training, even small data is also difficult for you to handle. A lot of pre-processing requires some documentation or whatever it is. Now obviously it's very, very expensive for you. Right? are infeasible, then what is the solution? Then deep learning won't be my choice. Deep learning won't be my choice. Then what do you expect to tell me? You have no training, no neural networks. Then what? Then everywhere people are deep learning. That's not a common solution for every problem. You explore only one direction, and what happens if deep learning is not a key for that, your problem? Then we go for other algorithm. Now my question is, somebody answer, when deep learning is not used, why? Because there is no training. When there is no training, what is the consequence? When there is no training, what is the implication? See, I'm going to give some hints to set some item in this room. Like hints is like training, some like treasure hunting. If I don't give any hints at all, what is the difference between these two problems? Unsupervised or unsupervised? What are you going to do? What is the problem in the second category when there is no training? Searching is hard. When there is no training, searching is hard. Eventually. Because there is no training, no learning happens. Because there is no learning, searching is hard. Therefore, we require search-based algorithms, heuristic-based algorithms, genetic algorithm, swarm intelligence, evolution computation model, all bio-inspired optimization algorithm, nature-inspired algorithm, ant-colony optimization, spider monkey, honeybee, firefly, dolphin scan, dolphin swarm, and then these shuffle frog, shuffle complex evolution algorithms, and plenty of thousands of optimization algorithms exist. Bad, binary bad, many more. Therefore, optimization. Why do you require optimization? Because set space is high. Why set space is high? Because there is no training. Because there is no learning happens. Set space is high. And we need optimization. Right? Therefore, we require the second category of set space optimization for the use. Right? Now, third category. Actually, we need not talk about the other two. I have to stop now. Technically, I have to go to the next slide. I need not give this 2 minutes discussion on the genetic algorithms, intelligence, whatever it is. But I am thinking is, you cannot have a deadlock when you don't know how to use deep learning because there is no training yet. Right? Therefore, use these all these evolution computation model, bias per optimization algorithm, genetic algorithm, swarm intelligence, particle sum optimization, all of them. Right? Because there was no training. So why do we require that? Because there is no training, set space is high. These algorithms, search-based algorithms, they help you in optimization. How you are going to identify. Now, third category. If it is not a training learning problem, if it is not a search-based problem, third is linguistic data, linguistic analytical process. I am going to measure a person so the role can be given with fuzzy data. We have linguistic analytical problem. That is fuzzy logic. Okay. So our interest is today on the first one, which we discussed for the last 15 minutes. Okay, 15 minutes. Deep learning based solution. Now, consider that we have a handful training data and we have a large one testing data, unsupervised data. Then what to do? What type of architectures we do? That's our challenge. Okay. Next slide. As I mentioned, like, how to define the deep learning? You see, please don't understand a simple architecture, go back and forget. See, you understand when to use deep learning and up to where you have to learn, up to how many hidden layers you have to use, where to stop, and what could be the possible accuracy, and how many epochs you have to run. All those technical concepts when you are going to implementing all those tools. So now, as I mentioned, you identify, see your dataset size, see the computation requirement taken for each epoch, and then see for every possible number of increasing of hidden layers, what is the number of, what is the change in the computation complexity, same time what is the improvement in the accuracy, then you try to balance between. As I mentioned, that's why it's very hard to define. You just try to go for up to 80% accuracy. 80% your type of data, type of features, how you are going to implement them. Right? So there's a marginal difference how you are going to choose that. right? So, but when you have no computational complexity requirements, obviously you are free to change as many number of hidden layers you want, such that the accuracy is at the maximum. Okay? So this is very tricky to define, as I mentioned. But having said this, if for example, if I increase the hidden layer, the accuracy is proportionately increasing. That's fair enough. Even though you have no computational problems, still you cannot increase the number of hidden layers just like that, because after some level, as I mentioned, deep learning always gives some better accuracy. We have a 0.001, but just for the 0.001, though you have no computational problems, still you cannot increase. You have to say like plus 1 increase, 80 to 82, plus 1, 2 hidden layer, 82 to 85. Then as when you increase, you bring 85.001. So that is exhausted. You cannot maximum get, I mean almost you have taken like a sugar cane juice, almost taken every information. Very difficult. And again the overfitting problems, all those things will come. Okay? So that's how we just compensate it. Or you can say the balance between the performance and the computational efficiency and the accuracy. Now I mentioned like no data set, no deep learning. No training, no deep learning. That's very, very important. Unless you have a proper training, supervised data, you have sufficient number of, I mean even large amount of data, so you will be able to handle it so easily. Right? The possible applications could be like natural language processing. But problem is when you have no training data, there are other ways also available for deal with. But anyway, today our focus is that also. But most of the application domains where we use deep learning is like some of you are giving some application domains where deep learning is heavily used nowadays. Medical imaging. Medical imaging is the one. If you observe, people are hesitant to take medical imaging or image processing or computer vision problems for their research nowadays. They consider them to be exhausted, not outdated, but still. Why? Because on every data set, lot of thousands of architectures people have developed, and they have become like very congested to come up with a new architecture. Right? It has become very challenging now, even if you observe. But still now, every day new problem we have seen like deepfake networks. Last 1 2 months we are hearing about a lot of thing about deepfake network where some celebrity are face some problems in it. Right? There is unless scope. No domain can be outdated. That's of course. Same time, when you take up such a problems, when you deal with, it is very, very difficult to publish. That you keep in mind. Right? Other domains, other than medical imaging, other than image processing or medical imaging, where else I can use this deep learning based solution? Security monitoring, obviously, where some training data set is required, I can use some intrusion detection system. Fine. Well, you can train how the specific object, where shape and contour of that, how to go with that specific, the character modeling, etc. Very fine. That's fine.
Spectral location.
Repeat?
Spectral location.
Spectrum allocation. That's fine. Real time. Yes. But the problem is this is real time. Right? Real time allocation. No? So deep learning is normally computational expense. Usually. Normally computational expense. We consider deep learning probably computational. They are not too expensive, but normally they are not computational efficient. So sometimes it's a challenge. But that's an application, right? Any other NLP? NLP, natural language processing? See, everyone should identify one problem statement by this session ending. Any other? That's all. Any other? Security also we can use some intrusion detection system, honeypot or any other architectures. We can train them. What are the previous existing attacker have a history of trying to train in these type of features are seen, these type of handle ID, these type of network address, this type of data packets, this type of access stuffs. Possibly put an attacker because already I trained my model. I have trained my model on some different attackers which are already seen in the prior art. Right? Then now I am going to train for the next attacks. Again, problem is what? What is the problem with using deep learning for security applications? Tell me. What is the problem for using deep learning for security applications? Same, again same. Unforeseen attacks, untrained attacks. If you are not trained, fine, all of these, if I train somebody to shoot, he can control, he can shoot somebody, but if you give me a weapon like some sword or something, he cannot handle it because he was not trained. Right? Same way, now deep learning used for security is like two-sided knife, because very important. If in case of unforeseen attacks, the models like deep learning are very challenging to deal with. Any problem? Any doubts? Tell me. No problem. Tell me. No problem. Be interactive. Yes. Tell me. No problem. Stand up and tell me. Yeah. Okay. You can ask at 10. Now, other than that, security, any other applications? NLP, natural language processing, we have an application. Tell me what? Okay, I'll give a domain to give an application. NLP. What application I give? Do you require deep learning in NLP? We require extremely. Too much we require. Why? Most of the applications is deep learning.
For text summarization.
Text summarization, yes. How to use deep learning? We train my model, I give a large volume text, how it is summarized also. We specify this could be, and we train the model and match it to those features or words. Here, word is a feature, Ashwin. Right? So that's a good text summarization, key phrase extraction, human computer dialogue systems, scholarly article detection, plagiarism detection. Plagiarism detection, X plus Y is A plus B by 2. Is this a plagiarism of that? Yes. Right? So, plenty of other applications. Most of the challenges like these, what is it? Human computer dialogue systems. Right? Human computer dialogue systems. What is the challenge? Where do you use deep learning there? Tell me. Where do you use deep learning? Human computer dialogue systems. You have used Alexa? Tell me. Alexa you have used, right? Is it a human computer dialogue system? Yes or no? Yes.
Yes.
Yes. Do you require deep learning there? Yes or no? Yes, you are already trained. If you say hello, Alexa, it says yes, please tell me something she asked and you just ask for some song and you sing. I mean, it performs it. Right? That's clearly human computer dialogue system where it was trained extremely on different voice commands, different type of voice input signal. It was trained on speech recognizers, speech analyzers, speech synthesizers. Right? Different voice input signal it was tested on. Various age group people it was tested on. Right? Various ambiguous words it was tested on. Everywhere you have trained extremely. Deep learning was too much used there. Without deep learning, no Alexa. Right? No Alexa. Right? That is NLP. In security we have talked about. Viruses and networks.
Insider attacks.
Pardon?
Insider attacks, like you can judge the gestures of an intruder.
That's right. That's right. Again, that's it. Correct. Sensor networks, virus networks, any application? Cloud computing, any application? Cloud computing, tell many of our career. Cloud computing. I chose many applications in the later slides. First you guess. Cloud computing, you don't need any deep learning based solutions. Security and cloud computing obviously require, other than security applications. Here for optimization also you can use a deep learning. Deep learning for optimization. I'll explain next slide. Like that, plenty of applications, but next slide. So the same whatever I already mentioned. Just most of the half of the slides I covered already. Just I will give a summarization now. Fine, whatever I have explained so far will come. Now, as I mentioned, how the performance of a deep learning based solution is going to increase with the increment in the size of the data set. That is the beauty and compared to any other learning algorithms. Right? Either they be asymptotic or may not be increasing with any performance. That is the reason we always be fascinated about deep learning based solutions. Right? If you observe the second point, whatever I have mentioned, it has a lot of unlabeled pattern and a handful amount of labeled patterns. That is the main requirement. Right? How big the data set size is, still if you have no sufficient patterns, training patterns, you will not be able to get a single feature from them. Therefore, the learning is least on large size data, which becomes a bottleneck and you cannot do anything. Right? And next, some specific example deep learning. Like we see, we have a network with multiple hidden layers, data visual networks, anything, right? Now, what type of contribution you expect? Other than like we have medical imaging data, like chest X-ray data, chest X-ray images. I take some the existing CNN architecture and I try to just make an experimental framework and try to see how much accuracy it is. Other than that, what type of contribution you expect? Because those type of works will become very common now. Just to take some existing, most of the deep learning problem is take some existing architecture, run on some data, get some simulation, plot it, write a paper. But that business is over. They are not accepting, no more. 5-6 years before or 10 years before, they used to accept like that. Now that experimental study won't work unless you add some novelty in the architecture. But we have, like, if you see in this figure, we have multiple hidden layers. Each hidden layer is having one autoencoder. You know what is an autoencoder? Right? Autoencoder, what happens? We take some features and send it to autoencoder and we try to extract the information and send it to the next layer. The hierarchy of the features. Right? Each hidden layer has an autoencoder for hidden layer 1, autoencoder for hidden layer 2, etc. Then they are going to aggregate, and when you are passing through each autoencoder features, you are going to get a better quality of features. This is actually dimensionality reduction or optimization we are making. Many people don't know that we can make optimization using deep learning, dimensionality reduction or feature extraction. We use this stack of autoencoders using for dimensionality reduction or feature extraction. Each autoencoder is extracting features. Like at 5 to 6 input layer, I get 3 output layers, output neurons. So this is used for dimensionality reduction, feature extraction. It's kind of optimization we are using deep learning networks. Right? Now what is the main contribution I can add here? People try to deal with like proposing new algebraic application functions, new aggregation functions. I'll show some sample aggregation functions which we develop in the next slide. And similarly, some people say, I think for hard learning, deep learning is very difficult to do, but I will have to add some novelty. Then you don't make any layer changes in the architecture, at least you take whatever the input layer you have, those x1, x2 and so on, xn, that input layer, those features you try to extract from some square optimization algorithm, some nature whispered algorithm, or some square intelligence or genetic algorithm. Use those features, whatever extracted as an input layer features for your deep learning architecture, which makes two issues. One is the computational complexity is coming down, same time with the better features you are starting, accuracy will increase, both ways. So the solution will be like so and so bias square algorithm based feature extraction for so and so deep learning architectures. Are you following me? This is adding some increment to the existing architecture by taking in new features, and then also improving the computational efficiency. Either this, right? Or if you want to theoretical complete technical contribution within a neural networks, deep learning architecture, you try to propose new or efficient algebraic activation functions, aggregation functions, and many more. There are a lot of ways where you possibly hit, right? And try to improve the network performance. Suitable activation function you take, aggregation function, or you try to select a better features. Most of them, what they do, if they, as I mentioned, we have a good amount of training data, large amount of unlabeled data, you try to take the input layer, neurons, will be selected from a bioinspired optimization algorithm like BAT or binary beta optimization. Once we are experimenting with the binary beta based feature extraction for some deep neural networks. So we have used binary beta optimization algorithm Don't ask me again what is binary pattern. That's an optimization algorithm. Most of you have heard most of it. So some optimization algorithm, any algorithm, optimize the features, use those features as an input layer features for your deep learning architecture, which makes them better, which makes the performance of the algorithm better, rather than the architecture better. Right? And as I mentioned, like some other we are dealing with some aggregation functions, how your features are going to be aggregated and getting some values such that you are going to see what could be the possible class for a given record. So if you see, we have taken some specific aggregation function here, aj equal to xj ej square, so on so, and we are using something called row there. Row is defined with a specific correlation between the features. Now what we have added here in this aggregation function is the correlation between the features when you are trying to make an aggregation between the features. So here what happens, when you use a correlation, it is difficult, it is easy to integrate the features of single step so that feature optimization can be easy for you. Okay, but of course, unless you are basic, you don't understand that. And how the layers are connected accordingly, we are going to see this. Next slide. Now some specific example we take, not only those what we have studied, talked about, any other. Most of when you talk about deep learning, most of them talk about some computer vision applications, CBIR. So let us see quite a few of them, then we will see other applications also. Okay? Now, many of you know what is the image segmentation problem, object detection problem. Broadly, most of the image processing problem we categorize as image enhancement, image segmentation, right? And other types, mostly. Then when we talk about this segmentation or object detection for the enhancement, either ways. Now, what is the difference between object detection and segmentation? So, my job is just I have to take a given image, I have to classify the objects like who are what. I need to classify. So, I need to detect the objects and also I need to segment. Now, what do you mean by image segmentation and image what you call object detection? Tell me.
Segmentation is a process to separate the complete image into sub-images.
Now, detection is difficult or this segmentation or classification? Object detection task is difficult or just a segmentation?
After completion of the object detection only, then we are going to segmentation. So that is obviously the object detection is the
Harder, because that is dependent on this, right? What is the challenge here? What is the main challenge in object detection?
so the detection of the object
Overlap
is based on the
regions.
Shape, okay.
Overlap regions.
overlapping also.
Okay, that's some contour edges and all. Any other? Object detection, the major challenge is, now if you see, like if you take there is a dog and there is a sheep, right? Most of the features of two different objects are same. They have tail, they have four legs, they are almost like similar structure, only with the height difference, right? So the major challenge in the object detection is what? This what class imbalance, misclassification problem, and feature extraction. These are the typical challenges we have unless we train properly. Again, deep learning is that's a clearly deep learning solution. The problem is what? If the training was not very limited, if the training data set is low, and eventually object detection becomes very challenging. The more training data size, eventually object detection becomes easier for you because you are trained on multiple diverse features, right? So your feature extraction is very important when we talk about, right? So object detection in a given image, and then segmentation, and then classification, right? So how do you segment the objects, or how do you first identify the objects, then segment, then categorize them, like what type of objects they are? This is very old conventional problem, it's not a very new problem. Object detection and segmentation. Eventually, how do we classify? Right? And I consider segmentation and classification problems are the same. If you say, I'm segmenting, eventually I'm classifying them. Those pixel regions are in test values, right? So they can be valued. Okay, this is one simple problem. The beginner level problems. They will start with a data set and try to identify similar objects. Next, image colorization problem. Not only now we see 4 or 5 image these computer vision problems, and we get into other problems. Don't worry. Now, image colorization problem. What is that? What is image colorization problem? Somebody give an example. I mean, just specify.
To apply the false colors to the grayscale image.
What?
To apply the false colors to the grayscale image, nothing but color image process.
Can different formally?
It is a pseudo color image process. That is not you apply the false color. We don't know the exact colors, but what the
I give you a gray level image, gray level. Then you need to colorize the image as if like it looks exactly to the actual colorized image. Right? Image colorization. No? What is the challenge here? Okay, how the training data would happen there for this problem? How about the training data for this problem? How the model could have trained or would have trained? Tell me.
we just identify the color models first of all.
Now, what happens? It trains those models as if this is the actual colorized image and it gives some level image, and then model makes some computations and finally it generates the actual colorized image and it matches pixel to pixel and say it's almost exactly same. If number of pixels are like 1% or less than 1%, they are differ, is a 99% accuracy. Then what do you expect? You claim that your model has 90%, 99% accuracy. Now look that's how we claim, right? If you have diabetes, there is a vaccine, happening 100 patients. Out of 100, 2 it is not working. I would say my drug has 98% success rate. Same way, right? No? Either way here, we are going to train our model on 100 images with different, I mean, gray level images and the colorized images, and see exactly in every image. Like, but problem is, one image I get some. Do we get the same accuracy in every image? You don't. Then how do you see the error in that model? Tell me. How to calculate the error?
Depending on the number of objects.
Image 1 I got some error. Image 2 I got some error. Assume the number of pixels not matching up properly, not colorized, whatever it is. Some specific measure we take obviously. Now image 1 I get some error. Image 2. My model is supervised on 100 images. Each image has some error. Somewhere maybe 100%, somewhere maybe 90, somewhere maybe 99. How do you see my error is your average?
Mean square.
Mean square error you want to take? Any other guess? Average error is correct. My question is it really the actual error?
No.
You can't say it. Right? This is very broad problem. You get some other image with different features. Right? Why that Lena image, why it is so popular? Why? That is not a specific image. I mean, captured for this type of purpose. But there are some challenging objects there in that image, lot of challenging objects. You know that Lena image you have seen, right? Why it is so challenging? Because image was looking like it's a challenge. And the contour, if you see, the shoulder contour is almost like very, I mean, different pixel values it has. Lot of such challenges are there. So when we take those benchmark images, they are not chosen just like that randomly. Lena image or any other such images. Right? So eventually what happens? Now these type of problems, now when we take, I have a model like average or whatever it is. Now our model, if I give such a gray level image, it should produce the colorized image which is actually exactly an image copy of the actual colorized image which is unsupervised. Right? That's called image colorization problem. Right? What are the applications of this model? Image colorization problem. What are the applications? One application. I have given the basic definitions and everything. I have talked about some application. Now I have given the application, image colorization problem. Where you can use it, you tell me. Where you can use this. Can you do something like the old black and white color, black and white movies I can convert to color movies? Right? Simple application, right? It's a layman application, yeah. Right? We have a terrorist photo which was captured 10 years, 20 years before. It's a black and white image. I can see the color image now. Plenty different applications, many applications, right? Okay. If you want an application, you should think out of the box. If you want to see, at least know the existing application, you should do the proper survey. Only then you will come. Okay. But next slide. And just if you can you go back once. Now if you see that one, first is the actual given image to the model. Second one is the model whatever we have developed, and third one is the actual, the original supervised image, the color image, right? And if you see like the first image, there may be slight difference in the color, like if you see middle image and the third image, they are slightly not same, but they are differ by some minor difference. The second image says each one is a different example. Second color and third color, they look like almost same. So you can say that this particular model, whatever you have used, the CNN or TENS or Alex and whatever I have taken for this data, it is working well for the second data set. First data is slightly, first image is slightly, because we can see a clear variation in the middle image and the last image. The second one is almost same, depending on its texture, intensity values and the type of features, whatever it is. Again, why it is working on one, why not other image? Again, we have to make some statistical analysis and see why, what is the challenging in that image. The major problem in image processing problems, I mean these models is, if it works on one image, we cannot guarantee it works on any other image, obviously. But it makes sense. So now photorealistic style transfer, another deep learning based solution we will talk about. We have an input image, we have an input image, and we give a reference image, and our job is to produce the reference or add the reference in the given input image where the reference is taken from the actual second image. So the third one is the image produced by your model, right? Tell me now, what is the reference you have taken from the reference image? First image, first example. Color or shape? See, we have the actual image, original image. Reference image is just to take a reference from that image. But final, what we are going to produce is the first original image with the added reference from the second image. That's called the photorealistic style transfer. Okay? So, a real reference from given reference image is added in the first image and make a realistic style transfer. Okay? So, now what is the image we are taking? What is the reference? Color. Color is anything else? May not be color, any other also. If you see, we have some water drops on the that reference image. If that also taken, then we have some water drops on that image, first image, which is colorized to whatever the color we have added. Okay? Anything else? Right? And second image, what is that? Is the original image. This is the reference image. Now, what is the reference we have added to first image? Tell me. What is the reference we have added? The first image. What is the reference here? Original image we have a reference image. What is the reference we added in the original image taken from the reference image? What is it? Huh? See, both images are not same. This is different, that is different. Not just, you see, the time is the feature we have added. This is the image, giving the features or information about an image captured in the night time, not daylight. So this has certain speeds. Now this is the reference. Now this image, if this image would have captured in the night time, how the first image looks like. Now if you see first and third images are same. Middle image is not the same geographical location, maybe some other city or whatever it is. But night time the images looks like this, the features are like that. Right? So now if at all that image would have captured in the daytime or in the night time, then how it looks like? That is the third image. Right? Now what would have the model taken in Delhi? Here? What the model would have been taken here? I mean from this second image. If you see, the contrast you see. First image, external contours are seen brightly, internals are not seen. If you see the other image is contrast. All the external entities or contours are seen with the dark black color, where the internals are seen. The internal, pixels are with bright. If you just see, it's completely contrast. Right? Like day and night, the contrast difference. Not exact. Something like that, the features are, the pixel would have transformed to different values, such that this becomes a so. Is it a colorized image? It's not just image colorization, it's beyond that. It's not just image colorization, it's beyond that. Okay? Are you following me? So it's very, very important. A photorealist. Where do we use again the applications? It's itself an application. Where do we really use them in real life applications? What else? Photo editing. Any other some VFX, graphics, movies, etc. If you see this was, when you see this in the first time, you tell me. First time, when you see this. When did you first experience this photorealistic style transfer? You see Titanic? There was a frame where the photo of the Rose Kate Winslet, it was converted from her teenage to exactly old age. So they have taken an actual image and a old age. When you see some YouTube videos, which reference they have taken, they have given us a documentary. The actual photo they have taken to convert the VFX is a different lady. Her photo was shown exactly with all these marks and everything. They have taken Kate Winslet photo, they have taken this as a reference and they converted that features. That's how the exact teenage girl photo is converted to a girl of an woman of 90 years of age. Right? That's called a photorealistic style transfer. Right? And many uses, many graphics movies, VFX movies. This is a very, very basic VFX operation. Okay? So those are interesting, those similar applications that you use. But this is very outdated, like it's not very new. Then how to add some novelty here? It's not a very new problem. That's a challenging problem. Not a very new problem. How we add some novelty? Tell me. Now convert this problem as a different problem. If this is the image, now reference I am taking from other image. I don't take from other image, I take time. If this is the image taken, like I take an image of some forest, right? Now I would like to transfer the image, like if this is captured in the monsoon season or let it be exactly winter season, how the same location works or looks to be in the summer season. Now you are adding, what is the feature there? Age. Okay, time, age. Does that you can have some predictions. They use something called generative AI or artificial general intelligence. Okay. I can only talk about the terms. Unless you have basics, you cannot understand obviously. Next. Now object removal techniques. Object removal. We have a given input image. Given input image, you remove an object. You remove an object and reconstruct the image how it looks like if the objects would have not been there. Where did you see this first in your life? Again, some movies only we have seen. Tell me. When you have seen some frames in the old movies, all of a sudden like somebody appears, disappears. How does that happen? That time you have no much VFX things and all those things. Tell me how it does happen. Nowadays movies, all of a sudden somebody disappears. How it happens? Tell me.
Different frames.
So one frame, unless they are present, the object the object may be a human. Unless the object or human is present, they maintain the frame. With the next frame, immediately they will remove that and then add a new frame. After some gap, they will shoot, but they will add immediately after this. They will attach the next frame without that. But now, how do they maintain? It's not so done so easily. If you observe, there are separate people who maintain the same frame, how it was there when the person was there. Same location is maintained for everyone who was there in the picture, except that objects which you are deleting. They will see that focal length and everything, they maintain angles exactly where it was, and immediately they will try to check. If the object is deleted exactly, the remaining parts to be maintained, remaining objects to be retained as it is. Okay, so that is masked by a fractional frame difference which goes, that's what normal frame when the scene is going on, when this appearance and disappearance, this happens. Now do you expect the frame rate to be same? No. Frame rate is different or you can say high for that particular adding of those two frames. Are you following me? When the person disappears and immediately appears. Now, if it is like, if you see when the fan is rotating, you will be able to see the entire ceiling. Why? Because it is going at very, very fast, you will be able to see the entire ceiling, though there is an obstacle. Why? Because the frame rate is very high. The frame is changing. One here frame is a blade. Right? That's how they mask the effect of gap. Okay? It's almost like similar. Now, we have a given object. And how I am going to remove an object? First I select what object I am. Then I reconstruct the image. Now, first and second image are same. But if I reconstruct the image, if the object is removed, how the image exactly looks like? That's the third image. Where do you use the same application like movies, VFX applications, etc.? Any other than movies? Tell me. Any other applications we have here? Any other? Some medical imaging applications, some tumors, etc. etc. If you have a typical tumor, if a tumor is removed, how the reconstructed image looks like, what is the affected region of the image, something like that. Right? In medical implantation and then the surgical oncology applications and all, etc. etc. they use. Next slide. No? On the other side of this problem, image, some object removal, we have image completion problem. Then you are removing and reconstructing. Where you have removed image and you are going to make it complete. But here, whatever you have removed, you are bringing back. Then you are removing and reconstructing. Completely opposite problem. Right? Not every such problem is easy. For example, if you see there, the last image, last example, every column is an example. Here every column is an example. Okay? For last, if you see the boy image, normally, he has some missing portion on his face. Certain features, textures are not available. Now, how do you go to make an image completion here? Tell me. How? See, not every image completion problem is easy. Not every image completion problem is difficult. Okay? Maybe some small break, madam? 5 minutes. I think you have got some tea, coffee. Let us break first. Okay? Just for 5 minutes. We have seen a couple of applications on that. Now, the same example, image completion problem. Given an image in some missing segments or some missing locations, Our job is how to complete this image by performing operation. Now, what is the logic behind that? Tell me. When you are going to make an operation on how to identify the missing patterns here.
Fill with
Neighborhood pixels and all you have to do. How exactly make it? Any segmentation helps you? Does all completion operations are same? Do the same? Can you like this? For example, you see the last image where there is a person with some missing portion of his face. Now, do we require have a lot of complex operations for every such missing problems? If you see, normally when such a specific segment of an image, if you see, already is one left eye or right eye is given to us. Normally, you see most of the times it is symmetric the other way. So we have a reference image. Because as a photorealistic style transfer, similar way, we have a reference. So there are multiple places. There we have a reference where we have, so it is as good as a supervised learning problem. Supervised, because we have got some training data. Already half of the portion of the face is there. Means we have a reference how exactly the person's face or the eye and the other similar structure looks like. So it is easy to fill. But if you see, not every problem is like that. There are some specific images where some unknown or untrained portion is missing. Then obviously it is difficult for us to make the, similarity or comparing the pixels, neighboring pixels, contours, various image processing operations, and then see what would be the possible image or possible value for a specific pixel, how such that we can identify. But the challenge here is, now among all these problems what we have seen, this is one of the toughest problem, image completion problem. Image object removal problem what we have seen, if you see, we remove an object and reconstruct. Fine. At least we have an idea what to remove and or you can say to reconstruct at least we have something here. But there the object is not to get back the actual deleted or removed object. But here we have to, if some object is missing, some portion is missing, you have to get it back, you have to reconstruct. Therefore, these type of problems are very challenging. Right? So again tell me what are the applications of this particular problem? Image completion problem. Tell me what are the applications of this? So some historic image restoration, something like that. Any other?
Medical applications where plastic surgery will be performed.
That is also a good application, very good application. Yes, that's right. Any other? Any other? Any other? In some medical imaging applications also we have, if you can identify a specific tumor of a specific site and some of the portion is not properly captured or identified by the diagnostic device. If you can predict the possible location and reconstruct the image, something like that. Some specific application in image processing, medical imaging, healthcare applications also can be there. Real-time application. We are not talking about practical implementation now, later. Deepfake network, which we are talking about nowadays, for the last couple of months, we are heavily hearing about this. Like, you know how the deepfake networks works? Anybody worked on that? Deepfake networks? Right? Why does it become more challenging nowadays? What is the challenge in deepfake images or deepfake video files? Now, the problem here with this type of networks is when you reconstruct an image, like whatever we have seen, the previous examples, image completion, object removal problem, etc. If I remove an object and reconstruct the image, for example, now had it been the original image when we see and the reconstructed image, if you are unable to find much difference, that's a very deep fake construction. This is not the actual image, we removed an object and we reconstructed, right? So in deepfake network what happens, we take a source image, we try to manipulate or alter the image with lot of inherent features such that we will not be able to identify so easily. That's because a deep fake. Why it's called a deep fake network is the moment I see the object, I will not be able to identify whether it is fake or not. You see now some of the bank experts, when they see a currency note, like they will just like that identify whether it is fake or not. But when we have deep fake notes, it's not only stopping here, deep fake currency. It's very difficult for the experts also to identify so easily unless they make a lot of, there are 17 to 18 features are there for every currency note, not exactly the number, some number. Right? Unless they see each of the feature reference and confirm, it's not so easy to say. Previously, those people who are printing the fake currency, they used to achieve up to 3 to 4 features to match, not all the features of a currency. But when the copycat when it's exactly copycat of that one, most of the features are matching. It becomes deep fake. When deep fake becomes original, tell me. When deep fake, we call it as the original or legitimate image. If you copy such a way, such that it is very difficult to extract, it's almost as good as an original image, we cannot retract and identify that it is a fake image. Now deepfake is in that direction. Now experts can identify, but not so easily. Fine. If you see a normal graphics movie and a high-end graphics movie, there is a huge difference, right? When we say that VFX the graphics effects are so high or high rated or high quality, tell me, when do we feel?
Looks like original.
When it looks like exactly original, then we call as highly graphical or highly graphical. See, fine. When you call as a VR device, a virtual reality device, to be very accurate and efficient, tell me. When we see a virtual VR, that what you call VR headset, VR headset. When we see, we should exactly feel that we should not be able to identify the difference between a virtual hologram, virtual image and an actual image. Then we say this is almost equal like a natural one. So it's very deep fake. Now the deepfake network what we have seen in the current days. Now how the deepfake network is constructed, many of you know. Any of you see deepfake networks? Use certain amount of convolution pooling layers and then reinforcement learning something perhaps, and then generative adversarial networks we use, right? It's not so basic CNN. That's why we call the deep CNN architecture we use. Generative adversarial networks we use, visual extraction we use, and then multiple convolution and pooling layers we use, etc. And thereby we construct a highly manipulated or altered image which almost looks like a same image. Unfortunately, there are a lot of apps are coming where we upload an image or feature and it will, and we select certain templates, it will automatically convert into the desired template with the front face as the person whom we are uploading. What is the research here, possible scope here, you tell me now? Only one scope, easily, right? Check whether the given image is a fake or not. Image or video file. It's fake or not. So you are going like what? You are going to have an anti-deepfake network. Right? Because now when we visualize, we cannot so easily conveniently say. Of course, it depends. Sometimes when you see the images so focusedly, you will be able to understand something abnormal in the image. Facial expressions, lip movements. Most of the problem it happens lip movements. Right? Natural language processing. And just forgot to mention. Deep belief network also requires some NLP engine, natural language processing engine. Right? NLP, gap, convolution pooling layers, and the feature extraction. That only makes your complete deep belief network. Right? Now, your possible tracer scope is what? To try to develop some architecture which could help in identifying the fake videos or fake images with some accuracy. What is the possibilities? Like, we should not be able to misclassify. A legitimate image can be fake image, and a fake image can be a legitimate image. Either is. Right? That is the main challenge we have. Right? So how your model now it's a 99% accuracy I've got with my model. Means what? Out of 100 images, 99 images properly identify whether a fake or not. One image it fails to identify whether fake or not, depending on what are the complex features involved and how accurate GAN networks they have used for to make such a fake network, and how the NLP engine they have used to convert that, and all those features. Experts can identify, but not all. No, that is a possible scope. And any other? Have you heard of digital twin? Anybody? There's some new research area which has lot of scope for the next one decade. Digital twin. Not identified? I'm going to, for example, a manufacturing company, automobile company, they're going to launch a vehicle. See, nowadays many times we are hearing that there is some problem in the fuel engine and they are calling back all the cars, right? If they have already solved out, about more than 2 lakhs cars, in every car they are calling back and doing the repair and again sending back. It's very expensive because there is a manufacturing defect, right? So what this digital twin does, before we produce or before we manufacture, we develop exactly a copycat type structure, but in a virtual environment. Exactly, digital twin. That's why I call it a digital twin, not the actual twin. In a digital object we create for the object which we are going to produce or manufacture. Then we make perform all the tests in a virtually real, in a virtual reality environment or wherever it is possible. Fine. In a digital world, you make all the tests to a digital object whose manufacturing is going to perform later, when it passes all the tests. Right? Digital, a lot of applications are there. Not only in automobile manufacturing, etc. Before a product is categorized or produced, you can have this. And similarly, you can have like in 3D printing, if somebody has some problem with the skull bone, and if you're going to have replacement with the 3D printing, then you can have exactly a digital 3D printing and check and compare with some MRI images exactly whether it is fitting or not. And many other side effects were there. That's why this concept of digital twin is very, growing a lot. There is possibly a lot of research scope. Digital twin. Now you can use some digital twin application using these deepfake networks. Your job is how effective digital twin you are going to design with the help of deepfake network. Every invention has made with a good purpose and how later it was misused. Fine. When deep belief network or deep fake network, deep belief network, many are there. Why this deep fake network was introduced? Tell me. For what purpose? Initially. What is the actual reason that they developed these type of networks? I think all these graphics moves like we have a hero there, like similar frame we are going to generate like multi-actor movie where there is a twin, something like that. That's a like kind of application, right? We are making exactly a digital twin of the person. It's like a deep fake. What was made for actually with a good intention. Not exactly the application, many other medical applications, biological applications, etc. Later it was used for this purpose. Right? 500 model was used for regular operations, it is used for every nonsense, something like that. So now the question is how we are going to use those applications of these deepfake networks for a specific real-time now digital twin application, healthcare applications, plenty of other applications we have. So we can use them. And but when those who work at this digital deepfake, they should be good at NLP. They should be good at NLP and MLP and computer vision. out there. Okay? Next is another important is multi-domain English to English translation. Multi-domain is I'll give a photo, input image as a photo of yours, and I will set in some features like some 100 features I have. One is like age, mood, height, weight, color, complexion, hair color, etc. A lot of features I'm going to give. Then to the given input image, whatever the feature I select, accordingly my given image has to be transformed to that particular form. Right? Whatever the features we are select, like different height, gender, if the same photo with a gender change how it looks like, and then age if it becomes some pet skin, etc. etc. Not only with the physical features like that, emotional features like angry, sad, laughing, crying, etc. etc. How the person looks like. Again, I am asking some application. What is the application of this? Tell me. Tell me. Not almost like Snapchat you have seen, right? Snapchat or something. It's almost like same, right? It's almost like. Is it exact Snapchat? There are a lot of templates out there. Snapchat, JPEG template has a feature like this. Like Snapchat, like same. Other way. Right? What is any other application other than wasting your time on Snapchat? Tell me. How many have not used Snapchat? Raise your hand. Okay. Okay. Now if anybody who did not raise, you raise your hand. Many people have not raised, no? So they have not used them. Yes. Now you tell me. Now, what is the difference between Snapchat and this application?
Adding effects.
Do they use this application?
Yes.
Do they use neural networks, CNN?
Some templates are like that, some weights are there and some
Yes,
have
right?
weights, like with different types of costumes also.
There, right? So now if you observe, are they really going to use all these CNN models, etc., etc.? Deep
Some of
CNN?
them
Obviously they require, right? Wherever image processing, obviously we require those models, right? Eventually. No, but problem is the snapshot. If you see, let's say again your research problem. Add more features or more applications for your snapshot. How we are going to add? Do you have that? You can hardly have templates where you can see a photo and you will be happy. Anything beyond that we can use this type of transformation. Any other application? Now see, if you integrate this with virtual reality, say snapshot in a virtual reality environment, you have a better graphical exposure, right? Snapchat is almost same, like similar application. When you use a virtual reality concept with multi-domain image to image translation, right? What happens? Over the time, now you are not going to have snapshot in your mobile. You would have in your VR goggles, right? VR goggles, where you see what that you are as if like whatever the image you want to transfer, you transfer and you are going to dance, right? If you cannot dance, you can dance on the screen. And over the time, you believe me, these heroes need not to act in the movie, they can only give their photo. Right? As if like we are seeing some dead actors are still being acted in the movie by way of using some VFX effects. Right? How we have seen. So it may so happen that the entire shoot can happen in a lab where the hero need not to come, he will only give his face. And it may so happen that there may be a hero who doesn't exist in the world, but who looks like exactly a human. And you go and watch his movie. And not immediately. That's all implications of this research. Fine. It may so happen that you marry to a person who don't exist. When somebody is marrying himself or herself, it's quite possible. You have heard, right? Some people are marrying themselves. What is some name? What is the name? I've heard the name. Forgot. Heard the name. Leave it. That's not part of our discussion. Now, so over the time that is possible. Fine. You can have a friend, virtual friend who don't exist. When that is possible, virtual reality and computer vision. CBI. Fine. Many beyond that, many are all I cannot speak. No? Next. So like this. Now another AI generated. Say now we have a given input image, and I'm going to generate AI generated summer image. If the image is captured in the winter and how the summer image for the same location. Now how it is going to happen? Tell me. How? Last page, I think you have some doubts. I'll ask you 2 questions at the end. No? This is the input image, this is the output image. You only, not the. No. Tell me. What is with just an image operations? That's all. This is again different problem.
Assumption that in summer we doesn't have any.
Now we have to see how much rainfall, possibly how much growth in those plants or trees, and then
Snow level.
what is the temperature? When the temperature is this one, how the sky looks like. Like many other parameters we have to consider. Right? That's what we call it AI generated summer image. What is the application again? Every image I am giving an application. Problem, base, problem, application. Right? Now tell me. What is the application of this? Weather forecasting, weather monitoring. Fine. Atmospheric monitoring. Fine. And for example, Himalaya, that glaciers, ice plates, and how much amount of ice was made for the last decade or 2 decades, and how much going to be made in the next 1 decade. Prediction, generative AI. Right? So all those challenges we get. Yes, sir? Any doubt? So similarly, many other applications. But then you have to see beyond, like that's why it's called generative AI. You have to take the atmospheric data of the last 10 years, and every year how much rainfall and what is the possible this temperature. So given date, you have to make an aggregation and see what would be the next 1 year, what is going to happen. Take some this analysis data. It is quite available this one. There is Sentinel-1 and Sentinel-2. Lot of data is available. When you talk about image processing, don't think only these basic image processing problems are there, and then some healthcare, medical imaging data. Beyond that, many people, 90%, 80% work in the image processing, medical imaging data. I don't know why. And remaining people work on these problems. Why nobody, I think many they don't take these NRSA data, remote sensing data, and other satellite data, AWS automatic weather station data. And they don't change detection, they don't take like dark vision this one. There is a movement of a ship in the sea or ocean. You will take remote sensing data. You can have the categorization of this. There is a marine ship or any other type of or any defense related ship or any terrorist related activities of sea malfunction, these malicious activities. And so that's what change detection problem. That's another problem, very good problem. Change detection using SAR images. SAR images. This other remote sensing data which can capture, which is already available in the remote sensing, that NRSA site, something if you see. There is Sentinel-1 and Sentinel-2 data sets are available, large volume size for a given geographical this one, region, where you can use it and make all this prediction when the ship is going on. The ship navigation and dark visual detection, whether it is a defense ship or a terrorist ship, something like that. A lot of applications are there. Don't only image processing side, make this medical imaging side, because that's completely exhaustive. Difficult to publish the paper. Many thousands of people have published on MRI, CT scan, ultrasound, diabetic retinopathy, chest X-ray images, other. Now you take a different domain and use all these operations CNN and whatever all we have seen. Right? Next minute. Again, unsupervised image to image transfer. Now it is unsupervised. It is not exactly a copycat type. Now we have a given image. All images belong to the same class of objects. Like we have cat, if you take ogre, cheetah, leopard, lion, and tiger. They belong to the same family. So in one side we are going to have all those categories organized. Something like that. So now what does this mean if I give this? It's almost like similar, it's not same as if I give you an image of yours. Your infant, I mean your childhood image, and when you are an adult, when you are very old, not that way. Here we have the same object. Here object of different classes, but they belong to the same family. It is something like that. You get some application. Now deep learning on NLP, most importantly. Deep learning, most of them we talked about so far what? Image processing. And other NLP applications. We can't always handle only CNN and deep CNN models, other division based CNN RM models. Now, deep learning and NLP, these are all the applications. There are plenty of applications. I am giving more than 100 applications today. Classification, language detection, if I specify language and you are going to see. If I speak a language, if the machine knows another language, we are going to categorize based on the features, audio input signal. Of course, we requires is when you are going to work on NLP, you should be very good at speech recognizer, speech analyzer, speech synthesizers. Right? So language detection, general topic detection. Right? That's one. Next thing is positive, negative, another sentiment analysis. Right? Sentiment analysis. Now, what is the positive, people's mood, and who is going to win the election, some predictions. Sentiment analysis is very, very challenging, and of course, for the last 1 year, it is not a very new problem, same time not very outdated, but unfortunately, not much work is going on in sentiment analysis because of the complex nature of the problem statement. Still, a lot of scope is there. It's not a very new problem, but a lot of scope is there. Right? Sentiment analysis for various applications. Where do you use these applications? Sentiment analysis, like if you see the editorial article, not exactly like that. You see like in this what do you call what is that? Key phrase extraction. If you talk about, if I give some text of some number of words, I'm going to key phrase extraction. What is the main key phrase of that text? In the entire text, what are the different key phrases? Not every sentence is used very liquid. So key phrases you extract, they are like features or tokens for you. And similarly, text summarization. If I take a text of some like an editorial article in a newspaper, I will summarize the text. After reading 1,000 words, I will summarize in 50 words what he wants to convey. He wants to criticize the government or appraise the government or praise the government. Right? Then at the end I can classify whether it is a biased coverage of an article or an unbiased coverage. It's a paid media or a non-paid media, genuine media, something like that. Right? All those applications. And then fact extraction, people and companion, geography, prices, dates, etc. Fact extraction. When you are speaking to somebody, if you ask like Arjun that all the time, you have small IoT device like that, smart bubbles, smart glasses, where it has some lens and it identifies your texture, your movements, etc., the way you are speaking, and how the body language and many other factors, and natural language, its intensity, factors, various. Then specify whether you are speaking truth or not, whether you are genuine or not, many other, right? Many other applications you can call it that. Then we have certain synonyms and authorship detection, plagiarism detection. If you can copy somewhere from somewhere. Normally we use some Tarantino certificate, right, for checking the plagiarism, right? But it's not so easy because there are some people who are very talented who copy and paste such that nobody can identify, right? Even the owner of the paper sees also it doesn't identify. That's also an art. Copy paste also an art. Many people they don't know, right? Many people they don't know. Now that's scholarly article detection, authorship detection, and then what else? Searching applications, question answering, or dialogue system. Mostly they are going to be similar problem because the dialogue system obviously requires some exchange of communication, question answering communication. Obviously it is required, right? And dialogue system, as I mentioned, Alexa type, and if you look at other now if you see over the time, Like if you see, if you're going to experience another pandemic situation, right? If you experience another pandemic situation, we expect, we are ready. What was the most demanding requirement during the pandemic situation? We have the lack of medical practitioners, sufficient number of medical practitioners, right? One is such. We have a computer-aided supporting system where a computer can see the basic symptoms of a person and suggest possible medication to them. Possible, right? With a doctor and computer, what is the difference? Doctor understand. Of course, there is a difference, human and computer. The way we sensitize and understand. Computer may not. Computer has a program, right? Now, when the doctor sees and understands something and obviously sees it, machine use deep learning, human use biological learning, biological neural model. He has already treated means he gained some experience. Machine is trained on some 100 patient, it has got some learning, supervised learning. So obviously what happens? If you train a computer-aided system which helps us to treat the patients by understanding his basic or general symptoms, he will hardly say, he will ask what is your problem, he will say headache. He will note the keyword headache, okay, and some pain, etc. etc. When you have so and so, what is the other symptoms, any side effects, etc. etc. Task. Then since how long it is lasting, those symptoms. Then finally it compiles everything and say you have possibly these are the problems. Then to detect that you have possibly these are the diagnostic tests you have to perform. Doctors also are doing the same thing, right? Right? But of course, their diagnosis is very different. Initially they sense these could be possibly something. Machine also does the same thing. Right? What is the difference between these two here? Okay? Doctors have experience which is realistic in nature. Where machine can possibly do a lot of mistakes, where humans, they cannot. The mistake that can easily caused by machines. So obviously what happens, such an application can be a dialogue system, an exchange system between human and a computer. There is no ceiling. Thousands of patients can go and I'm not talking about complex surgeries and all, a basic requirement of consulting the doctor for normal operations, normal medication problems, etc. So that is the other way. Online teaching. Online teaching, like when you have another pandemic situation, be ready with your entire database, data warehouse. Like you simply float the courses, BTech, CSC, BTech, so also online, completely online mode, where the computer teaches. There is an effective communication between the students and a teacher. There are pros and cons both. Anytime the student can access the computer, anytime he can attend the classes. So knowledge systems have a lot of role here, dialogue systems. So tell me, what do we need to learn in dialogue systems? To understand dialogue systems, to design something there, we need to be good at NLP first, natural language processing. Right? I just forgot to ask, do you know NLP first? Many of you? What is NLP? You don't know? Tell me. Faculty know many of them. I think I don't know everyone is faculty here or not. How many are students here? Raise your hands. Okay. Do you know what is NLP? Tell me. Natural language processing. What does that mean? I'm not asking affiliation. Tell me, what is NLP? What exactly? Now you tell me. Yes. Your last class. Yes, Joseph, tell me. We had you. Yes, tell me. What do you understand by NLP, natural language processing? No problem, try to. Yes. Don't know? What is natural language? Okay, sit up. Attend. So why do we require a separate domain to process the natural language which we speak every day? What is the realistic challenges involved there?
Because we have different types of models.
There are also different, we have C, C++, Java.
No, so natural human languages.
No, machine language also we have so many, right? Then what is this real-time challenge? What are the challenges in NLP? We are talking about all these applications, right? Can they be possible so easily? They are all out of the natural language, right? The major challenge in the natural language is very uncertain. The real time is different in text in a machine language. X is a variable of type integer, it has some bytes of memory. That's all. Predefined fixed meaning. Do you have any other meaning for X? No. NLP, if I say one word, 100 meanings I can get. Can we say yes or no? Right? And same word with a different intensity if I say. Again it has a meaning. Same word with different facial expression I say. Meaning is different. Right? That makes natural language is very tricky, complex, uncertain and ambiguous. That's why this is starting as a separate domain work for investigation, and in front of you a lot of applications are there. Right? Right? Over the time when the natural language goes to such a level, this NLP goes to such a level of imagination, lot of applications you can see. You can identify whether somebody is speaking genuinely or not, somebody is honest or not, somebody is lying or not. Yes. Who is this? Christian, stand up. Tell me, please stand up. Yes. Can you give me one application which I have not spoken? NLP, you have understood, right? Natural language, whatever the natural communication happening between you and me, that we are going to process and understand. Natural language processing. Can you give me one application out of, excluding this, whatever we have seen? It's just one application. What we can do by processing the natural language? Yes or no? You don't know? Excellent. Can somebody give me any, other than these applications, any one else?
Sentiment analysis.
Sentiment analysis already there, madam. Other than that? Anyone? Tell me, I think you're trying to say. No problem, tell me. I think you have something in your mind. Tell me, no problem. Maybe it is wrong, no issue. Tell me. No issue, no problem, tell me. Huh? Lie detection, huh? That could be a solution. So normal lie detection, we talk about existing lie detectors, they are using the brain signals and all that kind of. Oh, that's fine. You are also right. Now, when somebody lie means when it's a communication between parties, like natural language. So obviously you can see, but for that now what happens? Not only you require some facial expression, body language, etc., you have to take care of it. Possibly you can try.
Chatbots.
Chatbots, yes. But again we talk about dialogue systems and all. Part of that. That's fine. Chatbots is not. That's fine. Any other? So there are plenty of such applications as what we have seen many of them, and you try to see selected application that is quite able, but I have to say sentiment analysis, those are not very complex to use unless you have a good programming skills and a lot of data available, but you don't go. Right? Social media mining and public pulse, how to detect during the election time, etc. Now this exit polls and all, normally they try to see the communication between them. They ask some questions and based on that they try to announce. Now that if you take last 1 year's social mining data, like some Twitter data, X, and we try to process and say possibly this is the public pulse and who is going to win so and so, or in a given constituency, how we are going to see that. All these applications. Next one. And other deep learning and multimodal learning. And we say it's not only one object, we have multimodality applications we have. It's not only text or not only images. We have image caption generation. Some problem. Means there is an image, I'm going to generate a caption for that. Image caption generation. So we have images plus text to process in the computer vision operation. Similarly, search web by an image. Have you ever searched the web by an image? Most of you have not tried, right? Most of you, some of you may be tried. There are some tools exist for that, how to check properly. Video, see if I play a video, I'm going to describe or annotate the video such that I can understand. People will like not just a subtitles and all, etc. And similarly, speech recognition, anyhow, that's a well-known problem. And image classification, navigation, all these problems, multi-modal learning problems, we will talk about some deep learning based approaches. Next. So one such example, caption generation. If you take a given input image, we normally use Vision Deep CNN and some language language generating RNN. And we use these deep CNN and that one try to see the possible captions for that. We are going to have multiple captions, we rank them. The most suitable or fitting caption, we try to work with that. Right? And next, repeating same, I'll talk about next. Some unmanned aerial vehicle systems, autonomous driverless systems, drone control system, and many of the applications. Why? Because most of the data is, we have a CCTV camera like observation, which captures the image in real time. Those images can be identified, features extracted, real time the process, classified. And if you see the image is like based on the height and weight and the longitude, latitude, every difference is captured. And you're going to see the trial. If you see, the moment if you're going to identify possible the contours, if you see one is red, other is red, one is yellow and green. So green is the way that is the suggested direction in which the navigation to be possible. And yellow is the buffer. Red is the zone that is to be avoided. So how the drone control measurement, if you see, the deep CNN network is going to take the images and capture and process them on real time. And finally, the control system 3 it's a 3-class classification. And 3 classes, one is what? Turn left, go straight, turn right. 3 signal. If you see, first one is turn left, middle one is go straight, third one is turn right. Now, according to that that classification, tell me whether it is going to take left turn, straight or turn, right turn, and right. So we are going to capture. Now how this particular synchronization happens here, you tell me? It's the exact current location, this is the possible image and those images are processed realistically, and based on the features it says this is the nearest location where you can currently safely fly without any obstacle. If you fly in this direction, you are not going to encounter or going to have any other obstacle like that. Then it will possibly suggest. Yellow is the buffer, you can possibly go. Fine? Red should be avoided. That is the logic behind that. It is very important. This is using a simple deep CNN model, a drone management system how we are going to have. Obviously, there is a processor, there is an Arduino Raspberry Pi, how it executes everything. Next. So I think that's all. We are going to next phase, that will see tomorrow. Now this another 15 minutes, I'll leave for doubts.